So up until this point with Voronoi diagrams, you guys have learned how to actually create a Voronoi diagram, how to analyze one based off of, if a point is located at a certain spot, what is the closest site to it, et cetera, et cetera. Okay, you even did the U.S. map, so you created a huge Voronoi diagram with that, basically redistributing the space based off of the capitals in the U.S. Um, so you basically almost changed like our state lines and things like that. But today we're talking about adding a site to a Voronoi diagram. So today you're going to be learning how to alter a Voronoi diagram when a new site is added to existing sites already. Okay? So for example, let's say you have a company like Chick-fil-A. Okay? Chick-fil-A has their respective locations along Central Florida, and big business they want to increase their income, so they want to add in a new Chick-fil-A site to what they already have. They have to try to figure out, okay, well, where am I going to place this new Chick-fil-A to make sure that I'm not pulling from, the business of another Chick-fil-A. That is considered adding in a site. Okay? So we're going to talk about that today. All right? Now, when a site is added to a Voronoi diagram, like I said before, the diagram has got to be altered. Okay? There's three steps when you do this. And step 2 can be repeated multiple times depending. So, step 1 says to identify PI whose cell contains the new site X. PI represents one of the sites that is already located on your Voronoi diagram. Okay? So I can't say A, I can't say B because it's dependent on what you're given in the question. So P sub I basically represents a site that is already on your Voronoi diagram. Okay? And it's specifically the site whose cell contains the new site that we want to build. Okay? From there, you're going to construct a perpendicular bisector within this cell. Okay? I'm going to abbreviate perpendicular bisector as PB. Okay? You're going to see me do that often. And I'm going to construct a perpendicular bisector between You're going to construct a perpendicular bisector between that site that's already that site that's already on your Voronoi diagram and the new site that you're trying to build in. So you're going to construct a perpendicular bisector within that cell. At any point where this line meets an existing edge, you create a vertex. So you're actually going to draw in that perpendicular bisector. You're actually going to draw in that line. And if that line intersects an existing edge of a Voronoi diagram, then you have created a vertex. Does everybody understand? So, inside of a Voronoi diagram, you're going to have sites. Okay? Here's an example of a Voronoi diagram. You have all these different sites. Okay? A new site is going to be placed somewhere within one of the cells already that's there. A cell is basically a region that's divided by the edges of the Voronoi. Okay? So, you identified PI. PI represents one of the sites that already exists within the cell that contains the new site. So basically, out of these 3 blue sites, A, B, and C, which site am I going to use to construct this perpendicular bisector? You're going to use C because it's in the same cell. So you construct a perpendicular bisector. A perpendicular bisector is a line. You're actually going to draw that line. In order to draw a line, you probably need an equation, right? What 2 things do you need to create an equation? Gradient, not a y-intercept. It's a perpendicular bisector. You have to be specific. You need a midpoint, okay? Because that midpoint is going to be that point that you use to draw that line, okay? It's not going to go through a y-intercept. It might, but it's not always going to go through the y-intercept. So you construct that line. You draw that line within the cell. If that line intersects an existing edge or meets another edge, right? So you draw on that perpendicular bisector. If it happens to meet one of the other edges, in other words, one of the other parts of that Voronoi diagram, you created a vertex. That's what that means. Okay? Once you've done that, for each site, P sub j, whose cell is adjacent to the new vertex, you construct yet another perpendicular bisector with that cell through the vertex. Okay? So, that basically means for each adjacent site, what does adjacent mean? Next to. So for any site, different site, mind you, that's next to that new vertex that you create, you need to construct another perpendicular bisector, okay, with that new site and the site that's being added in. And again, if you end up creating that perpendicular bisector and it intersects again with another existing edge, you have to continue to repeat this process until it doesn't intersect any more edges. Okay? So step 2 can be repeated multiple times. Once you've gotten to the point where you constructed your perpendicular bisector and it doesn't intersect any more sides, then what you do is you remove any segments of the edges from the original Voronoi diagram, which now lie within the new cell of the site that we've added in. That's why I said if you have a highlighter, go ahead and pull that out, because when we construct this new Voronoi, we need to see exactly what that diagram looks like. Okay? 3 steps. Step 2 can be repeated multiple times. Let's look at an example. Here's an example of a Voronoi diagram that represents hospitals. A new hospital is being built at site D in the Voronoi diagram, showing the hospitals that already exist, which are A, B, and C. Okay? Now, for this particular one, I am going through, and I've already added in the respective steps. But the second example, I don't have those steps in of exactly what perpendicular bisectors you need to draw in. So, step 1. Let's go back. Flip back in your foldable. Step 1 says identify P sub I whose cell contains the new site. In other words, which existing site and what cell is D, the new hospital that's being built, is within. It's within B. So you've done the first thing so far. Now what we're going to do is we're going to construct a perpendicular bisector between what 2 points? A little louder. B and D. Okay? So we need to construct a perpendicular bisector between B and D. In order to do that, I need a point. What point? The midpoint. I need the midpoint of BD. And I'm also going to need the gradient. Now, I need the gradient of what? I need the gradient of BD, but am I going to use that gradient to create the perpendicular bisector? No, I need to do the what? Opposite reciprocal, because it's a perpendicular bisector, so you have to do the opposite reciprocal slope. So I need the gradient of the perpendicular bisector of BD. Those are the 2 things that I need. Let's find the midpoint between B and D. B is located where? 2, 0. D is located 4, 4. Okay? I need to find the midpoint between those 2 points. Midpoint, how do I find it? What do I need to do?
X1 plus X2 divided by 2. X and a Y1 plus Y2 divided by 2.
Very good. X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. 4 plus 2 is? 6 divided by 2 is? 4 plus 0? 4 divided by 2? So there's your midpoint at 3, 2. You need to plot that point because that's the point I'm going to use to basically graph the line that is my perpendicular bisector. Okay? Now I just need the slope. Now I need the slope of AB. I'm sorry, not AB, I'm sorry, BD. How do I find slope? Y2 minus Y1 over X2 minus X1. So that's 4 minus 0 over 4 minus 2. That becomes what over what? So the slope is, and that represents BD. But the slope I want is the perpendicular slope, which is going to be what? Negative 1/2. So negative 1/2 is the slope that I need for my perpendicular bisector, and I'm going to graph the line using the slope from the midpoint, not the y-intercept, okay? I got to stay within that cell. So from the midpoint, which is right here, I'm going to go down 1 over 2, down 1 over 2, and I'm out of the graph right now. Do you think if I continue to go down 1 over 2, I'm going to intersect another edge in my Voronoi diagram? No, because the only other even close edge is this one, and they are increasing. Okay? So if I continue to go down 1 over 2, I'm not going to intersect. But remember, it's a full line, so I need to go back as well. Let me graph this. From the midpoint, what will I need to do to get the ones to the left of that? Up 1, left 2. And as you can see, now I've intersected with one of the edges. Question? Oh, because remember, a slope is rise over run. So you do your y's first, either up or down, and then you run to the right. So now that I've intersected one of the edges, I can stop, and I can draw my line. Okay, so let's draw our line of our perpendicular bisector. This is all step 1. Questions? Now, if you go back and look at your steps, step 2 says for each side EJ, whose cell is adjacent to the new vertex, you need to construct another perpendicular bisector. So from the vertex was this point that intersected with the edge of the Voronoi diagram. Which site is closest to that vertex? Well, D is the new site that we're adding in, so I'm not going to use that, but the closest actual site that's already there is A. I'm not going to use B because I just used B to create that new vertex. It's A. It wouldn't be C because I'm crossing over another edge to get to C if I'm basically having to construct a perpendicular bisector, so the closest one is A. I now have to create a perpendicular bisector with A and D. So again, I need the two things. I need my what and my what? Midpoint and gradient. Question? So I need the midpoint of AD. Where's A located? So -2, 4. So I need my midpoint of AD. So again, I'm going to do x2 or x1 plus x2 over 2. y1 plus y2 over 2 to get the midpoint. What's -2 plus 4? Divided by 2? 1. What's 4 plus 4? Divided by 2? There's my midpoint, 1, 4. So I'm going to plot that. And now I need the gradient of my perpendicular bisector of AD. Well, I mean, can we kind of see already what is the slope of AD? I were to draw a line that connects A to D, it would be a horizontal line. What's the slope of a horizontal line?
0.
It would be 0. Okay? So what is the perpendicular slope to a slope that's already 0? It's undefined. So the slope we need is an undefined slope. What do lines look like that have an undefined slope? They're vertical. So through that point, that midpoint, I'm going to draw a vertical line. Make this nice. Like so. If I continue with that line, is it going to intersect another edge of my Voronoi diagram? If I keep going up? No, it won't. So because, as you can see in step 2, it says repeat this process so no more new vertices are created. Well, if I keep going, I'm not going to intersect with another edge. So I'm done. Okay? Step 3 says remove any segments of edges from the original Voronoi diagram which now lie in cell X. So basically, I do not need this part anymore because I've created a new cell that now contains D and is enclosed by those red dotted lines. So with my highlighter, I'm going to go through and I'm going to trace over where my new Voronoi diagram is. Okay? This part never changed, so that's still there. Same with this edge as well. The difference comes right here. I have this edge that I just highlighted, but now I have the new dotted red lines as my other edges, and that is my new Voronoi diagram after adding in site D, or hospital D. And remember, sites are always equidistant from those edges, okay? So B is the same distance away from that red perpendicular bisector that D is. Same thing, A is the same distance away from that vertical perpendicular bisector that D is. All the other ones are still the same. Questions? Yes?
It says remove any segments or edges from the original Voronoi diagram, which line cell X. So how do you know which one is cell X?
Cell X is the new site that got added in, so in this case it was D.
Excuse me, Ms. Anderson?
So we're going to redraw this Voronoi diagram with an additional site at -1, 1. That's labeled E. Does everybody see it? Yes? Okay. So step 1. Step 1 says that we need to do what? What's the first thing that we did? Before we can draw the perpendicular bisector, we have to identify the closest site. What's the closest site to E? D. Now that we've identified it, we need to construct the perpendicular bisector between what 2 points? E and D. Okay, so let's go ahead and find that perpendicular bisector for D and E. I need the midpoint of DE. Okay? What's the midpoint? I can see it. That's why I'm looking at it.
-3, 1.
Huh?
-3, 1.
A -3, 1. -3, 0.
Oh.
Okay? Again, you can do x1 plus x2 over 2, y1 plus y2 over 2 to get the midpoint. Okay? Now I need the gradient of the perpendicular bisector for DE. First off, I'm gonna do this the way that I did it, okay? Because I know that slope is gradient is rise over run, right? To get from D to E, I go up 1 or up 2 over 2. What's 2 over 2? 1. So the slope of DE is 1. So then that means the perpendicular bisector slope is going to be -1. Okay? I want to use the actual graph to do my slope instead of going through and doing the formula. Okay? Yes?
Wait, how did you get 1?
From D to E, I go up 2 over 2. So up 2 over 2, that gives me 1.
You can do that with all of them?
Yes. Instead of using the formula. That's why when I went over gradient, I was like, what are the other ways to represent that? Rise or run. If you know 2 points is on a graph, and it's a nice graph like this, why not? If not, you can use the formula. You can always use the formula.
Point E is at -2, 1, not 1.
Okay. So now I need to plot my midpoint at negative 3, 0. And I need to apply my slope, which is negative 1. So from that point, I'm going to go how? Down 1.
Over.
Which way? Not to the left. To the right. Down 1, right 1. Down 1, right 1. Until I intersect with one of the edges, which I have at this point. Remember, negative slopes, they go down to the right. So that's why I had to go always to the right one. What about getting some points that are to the left? From the midpoint, I would need to go the opposite. So instead of going down 1, right 1, I would go up 1, left 1. Up 1, left 1. Again, until I intersect with one of the edges, which I have at this point. When I draw my line, I have constructed my perpendicular bisector. And I've created a new vertex. Now, step 2 says to do what? So I need to construct another perpendicular bisector. So what are going to be the 2 points I'm going to construct a perpendicular bisector between? A and E. Very good. So step 2, I'm going to continue to use the space. I need to construct a perpendicular bisector between A and E. So I need the midpoint of AE, and I need the gradient of the perpendicular bisector for AE. Are you guys catching on? Midpoints and perpendicular midpoints and gradients. Perpendicular bisectors. Identify what's the closest site to the new site you're trying to add in. Okay? And I'm going to go ahead and tell you that the midpoint between A and E is negative 3, 3, because I am running short of time, but of course you can always do the formula. And then the slope of AE is a negative 2. So I need the perpendicular slope to negative 2. What's the perpendicular slope to negative 2? 1/2. So then that means from the midpoint at negative 3, 3, I need to go down 1 over 2, up 1 over 2, up 1 over 2, because it's a positive 1/2. So from the midpoint, I go up 1 over 2, and what happens the first time I do that? I hit an edge, and I stop, right? Because I'm going to have to repeat this process again because I've hit another edge. The only time I can stop this process is if I end up not hitting any more edges. Okay? And then again from the midpoint, instead of going up 1 over 2, I can go down 1, left 2, and I'm back at that original vertex. Again, I've created a perpendicular bisector. I'm starting to enclose site E in its new cell. I have a new vertex. So I need to construct another perpendicular bisector, this time between what 2 points? B and C, because I'm trying to enclose E. So because we hit another edge, we have to create another perpendicular bisector, this time between A and B. So we are going to find the midpoint of BC, and we're going to find the gradient of the perpendicular bisector for BC. So the midpoint of BC is going to be 2, 2. Again, we can use our formula for midpoint to find 2, 2. And then the slope is undefined because it makes a vertical line. So if BC is undefined, the perpendicular slope of that would be 0. Okay? Vertical and horizontal lines, they are perpendicular to each other, so an undefined slope, perpendicular slope would be, or perpendicular gradient would be 0. So then, from the midpoint, we are going to Sorry, you guys. I actually made a mistake here. I'm not finding the midpoint between BC or the gradient of BC. It's between the nearest site to that new vertex and the site that we're trying to add in. So I actually should be finding the midpoint of BE and the gradient of BE. So that was my mistake. I knew something was wrong, so like this is not making any sense. So let me try that again. I need to find the midpoint of BE. The midpoint of BE is going to be 0, 3. And then the gradient of BE, which I'm going to need to find the perpendicular gradient, is positive 1. So then the gradient that I need is going to be negative 1. So from 0, 3, I'm going to go down 1 over 1, and again, I'm touching an edge. Again, from 0, 3, I'm going to go up 1, left 1, and again, I'm touching an edge to create another perpendicular bisector. And because I've hit another edge, I have to continue to keep going and creating perpendicular bisectors to basically create my cell for E. And as you can see, hopefully they're starting to enclose E, and I probably just need just this one more, midpoint and gradient of CE to finally close in that cell that's going to add in that additional site of E. So I need the midpoint of CE, which is the 0, 0. And then the gradient of CE is going to be a negative 1/2. So the perpendicular slope of CE is going to be positive 2. So from there, I'm going to go up 2 over 1. But I really don't need this one because, again, it's almost like I'm cutting into the cell for B. But I can go down to left 1, down to left 1. And actually, I should start from my midpoint. I didn't pop my midpoint. I went from the vertical. That was an accident. Start from your midpoint, then go up 2 over 1, and then you'll be at one of your edges. Down 2 over 1, you'll be at one of your edges. So when we connect for that perpendicular bisector, we're done. We basically be repeating the process of going back over the perpendicular bisector that we created for DE, and we have added in our additional site. So, because I can't go anymore, I'm going to remove the ones I don't need. Okay? So the ones that I don't need are all the ones that are in the middle that were created when E wasn't even there. So with my highlighter, I'm going to go over, of course, my new red dotted lines because that's the cell that encloses E, and then over all the edges that remain and that contain the other sites as well. And that is my new Voronoi diagram. Hope I didn't confuse you guys too bad. Go ahead and make sure that you attempt your homework, and I'll address any questions next class.